The authority having jurisdiction in this area is the local building department. According to the local building department, low-voltage lines such as doorbell, thermostat, and cable television lines can be installed in framing members like 2x4s and steel studs if they are enclosed in a raceway or cable tray. The raceway or cable tray must be installed in a manner that maintains a minimum of 1 inch of clearance from combustible materials. The National Electrical Code, or NEC, requires a minimum of 2 inches of clearance between low-voltage lines and other conductors or combustible materials unless the low-voltage lines are firstly installed in a raceway or cable tray or secondly separated from other conductors or combustible materials by a barrier. Michael Figure 820.24 shows that low-voltage lines can be installed within 2 inches of other conductors or combustible materials if they are firstly protected by a non-conductive covering or sleeving or secondly installed in a raceway or cable tray. There is some confusion on this point because the NEC does not specifically allow low-voltage lines to be installed within 2 inches of other conductors or combustible materials if they are protected by a non-conductive covering or sleeving. However, the authority having jurisdiction in this area interprets the NEC to allow this type of installation. In this area, low-voltage lines can be installed in framing members like 2x4s and steel studs if they are enclosed in a raceway or cable tray. The raceway or cable tray must be installed in a manner that maintains a minimum of 1 inch of clearance from combustible materials. Now let's delve deeper into the specific requirements and considerations for installing low-voltage wiring in framing members, referencing relevant sections of the National Electrical Code, or NEC, and common industry practices. Firstly, we must define what constitutes low voltage in this context. Generally, low voltage is considered to be 50 volts or less alternating current or direct current. This includes wiring for doorbells, thermostats, security systems, cable television, and network cabling such as CAT5 or CAT6. The NEC provides specific guidelines for low-voltage wiring in Chapter 7 and Chapter 8, depending on the application. Secondly, let's address the concerns regarding the installation of low-voltage wiring within framing members, such as wood studs or steel studs. The primary concern is the potential for physical damage to the wiring, which could lead to short circuits, fire hazards, or signal degradation. The NEC addresses this concern by requiring that wiring be protected from physical damage. One common method of protection is to install the wiring within a raceway or cable tray. A raceway is an enclosed channel designed to hold wires or cables. Examples of raceways include electrical metallic tubing, or rigid metal conduit, or RMC, and non-metallic conduit, or PVC. Cable trays are typically used for larger cable runs and provide a support system for multiple cables. When using a raceway or cable tray, the NEC requires that it be securely fastened to the framing members and that the wiring be properly supported within the raceway or cable tray. Another method of protection is to use a non-conductive covering or sleeving to protect the wiring. This is commonly done with flexible non-metallic tubing, or ENT, also known as Smurf tube. ENT can be easily fished through walls and ceilings and provides a degree of protection against physical damage. However, it is important to note that ENT is not a substitute for a raceway in all situations. The NEC specifies when ENT can be used and when a more robust raceway is required. Now let's discuss the 2-inch rule mentioned earlier. The NEC generally requires a minimum of 2 inches of clearance between low-voltage wiring and other conductors or combustible materials. This clearance is intended to prevent the spread of fire and to reduce the risk of electrical interference. However, there are exceptions to this rule. As mentioned earlier, if the low-voltage wiring is installed in a raceway or cable tray, the 2-inch clearance is not required. Similarly, if the wiring is separated from other conductors or combustible materials by a barrier, the 2-inch clearance is not required. The barrier must be made of a non-combustible material, such as metal or concrete. It is important to note that the authority having jurisdiction, or AUJ, has the final say in interpreting and enforcing the NEC. The AHA may have additional requirements or interpretations that are specific to the local area. Therefore, it is always a good idea to consult with the AHA before beginning any electrical work. In some cases, the AHJ may allow low-voltage wiring to be installed within 2 inches of other conductors or combustible materials if it is protected by a non-conductive covering or sleeving. This interpretation is based on the principle that the non-conductive covering or sleeving provides adequate protection against physical damage and reduces the risk of fire. However, it is important to obtain written approval from the AHJ before using this method of installation. Now let's consider some specific examples of how these rules apply in practice. Firstly, a doorbell transformer is typically installed near the main electrical panel and the low-voltage wiring is run to the doorbell chime and the doorbell button. In this case, the low-voltage wiring can be run through the wall cavity without a raceway, provided that it is protected from physical damage. This can be achieved by using a non-conductive covering or sleeving or by routing the wiring in a location where it is not likely to be damaged. Secondly, a thermostat is typically installed on an interior wall and the low-voltage wiring is run to the heating and cooling equipment. In this case, the low-voltage wiring can be run through the wall cavity without a raceway, provided that it is protected from physical damage. This can be achieved by using a non-conductive covering or sleeving or by routing the wiring in a location where it is not likely to be damaged. Thirdly, cable television wiring is typically run from the service entrance to the various television outlets in the house. In this case, the low-voltage wiring can be run through the wall cavity without a raceway, provided that it is protected from physical damage. This can be achieved by using a non-conductive covering or sleeving or by routing the wiring in a location where it is not likely to be damaged. In all of these examples, it is important to ensure that the low-voltage wiring is properly supported and secured to the framing members. This will prevent the wiring from sagging or becoming damaged over time. It is also important to avoid running the wiring in locations where it is likely to be exposed to moisture or extreme temperatures. In summary, the installation of low-voltage wiring in framing members requires careful consideration of the NEC requirements and the local AHJ interpretations. By following these guidelines, you can ensure that the wiring is installed safely and correctly. Remember to always consult with a qualified electrician if you have any questions or concerns. To further elaborate on the installation practices, let's discuss specific techniques for securing and protecting low-voltage cables within framing. Proper securing methods not only prevent damage but also ensure the longevity and reliability of the low-voltage system. Firstly, when running low-voltage cables through studs, ensure that the holes drilled are appropriately sized. The NEC typically requires that holes drilled in wood studs for wiring be at least 1 and 1/4 inches from the edge of the stud, or that the stud is protected by a steel plate. This prevents nails or screws from penetrating the cable during drywall installation. For steel studs, use grommets or bushings to protect the cable from sharp edges of the stud openings. These grommets provide a smooth, rounded surface that prevents abrasion and potential damage to the cable insulation. Secondly, cable staples or cable ties are essential for securing the cable runs along the framing. Use insulated staples that are specifically designed for low-voltage cables. These staples prevent the cable from being pinched or damaged. Ensure that the staples are not over-tightened, as this can compress the cable and affect its performance. Cable ties can be used to bundle multiple cables together, providing a neat and organized installation. When using cable ties, avoid over-tightening them, as this can also damage the cables. Thirdly, consider the routing of the cables. Avoid running cables in areas where they are likely to be exposed to physical damage, such as near doorways or in high-traffic areas. When crossing framing members, use protective measures such as running the cable through a conduit or using a cable tray. This provides an additional layer of protection against impact and abrasion. Fourthly, pay attention to the type of cable being used. Different types of low-voltage cables have different insulation ratings and are suitable for different applications. For example, plenum-rated cables are required for installations in air-handling spaces such as above suspended ceilings or in raised floors. These cables are designed to be fire-resistant and produce minimal smoke in the event of a fire. Fifthly, grounding and bonding are important considerations for low-voltage systems. While low-voltage systems typically do not carry high currents, grounding and bonding can help to prevent electrical noise and interference. Follow the manufacturer's instructions for grounding and bonding the equipment and cables. Sixthly, labeling and documentation are often overlooked but are essential for future maintenance and troubleshooting. Label all cables and terminations clearly, indicating the purpose and destination of each cable. Keep a detailed record of the cable routes and connections. This will save time and effort when troubleshooting problems or making changes to the system in the future. Seventhly, when working with existing structures, be aware of the presence of other utilities such as electrical wiring, plumbing, and gas lines. Maintain a safe distance from these utilities and avoid damaging them. If you are unsure of the location of these utilities, contact the local utility companies for assistance. Eighthly, consider the impact of temperature and humidity on the low-voltage system. Extreme temperatures and humidity can affect the performance and longevity of the cables and equipment. Use cables and equipment that are rated for the environmental conditions in the installation location. In addition to these practical considerations, it is important to stay up to date with the latest changes to the NEC and other relevant codes and standards. The electrical industry is constantly evolving, and new technologies and installation methods are being developed all the time. By staying informed, you can ensure that you are providing the safest and most reliable low-voltage systems possible. In conclusion, the installation of low-voltage wiring and framing members requires a thorough understanding of the NEC requirements, local AHA interpretations, and best practices. By following these guidelines, you can ensure that the wiring is installed safely, correctly, and in compliance with all applicable codes and standards.